Okay, now solving, so we did solving graphically, which is a perfectly fine method. It's a good method for solving. But there is also a table method, and it emulates, if you do go on to either Business Calc or Calc, there's a process that they use to test whether certain functions are positive or negative. And they do that using a table, either a table or a numerical set of values. And so this emulates a lot what you do there. So that's why we like to go over here in college algebra. But like I said, graphically also works. You can always solve it graphically. Alright, but we will learn how to do it with the algebraic method. Alright, so the algebraic method in testing values using tables. Alright, so step 1 is always the same. Write the inequality equal to, greater than or equal to 0, less than or equal to 0, or, set it to 0. Solve for the zeros, right? Those are your boundaries. Right, these are your zeros that you want. Those are what we'll consider the boundaries in our intervals that we're looking at. Right, so use those boundaries, the zeros, right? The boundaries are the zeros. Use your boundary numbers to separate the numbers into intervals. So again, the zeros are going to be where the function 0. Those are your boundaries. Between the zeros, why they're called boundaries, is where your function's either going to be positive or negative. Alright, so that's what they're telling you to do here, is between each of those zeros, over all of the boundaries, separated, by your zeros, it's either always positive or always negative. And so that's what we're going to test for. We're going to test, well, when is it positive or negative? And so the step 4 is to do that. You pick a test value on each interval. Alright, so you're going to take a number that's on, so if my interval is from 1 to 10, I pick a number between 1 and 10, so 1 would be a 0 and 10 would be a 0, and I plug it into my quadratic to see if it's positive or negative. Or if it's positive on that piece, and that means it should be negative on the other pieces. And then you write your answer. Once you figure out when it's positive or negative, you know when it's greater than or equal to 0, less than or equal to 0, or greater than 0, or less than 0. Alright, so I'm going to walk you through an example, and then we'll do another one altogether. Alright, so suppose we want to solve this inequality. Alright, I want to find when is x squared greater than or equal to 2 minus x. Alright, symbolically means using the table in algebra. Write the solution set in interval notation. Alright, so first thing we have to do is we have to rewrite that. And so they do that. So x squared plus x minus 2 is what we get. We started out with x squared greater than or equal to 2 minus x. And so what they did is they moved both of those over. They subtracted the 2 and they added the x. So subtract 2 and add the x, and then they write them in the right order. X squared plus x minus 2. Over here, those zero out, and so we'll be left with x squared plus x minus 2 greater than or equal to 0, this is what we get. So this is what we're going to solve. Alright, first step is find those zeros, those boundary points. So solve the quadratic equation. Solve specifically for your zeros. That's what you're solving for. When is the function 0? Those are going to be your boundary numbers, right? The zeros are your boundary numbers. Right, so they're important that we find them. Right, so this case it's a simple, my set equal to 0. It's a simple factor case. So you take your x squared plus x minus 2. It factors into x plus 2, x minus 1. And so there are my zeros. So that's when the function equals 0, which are my boundaries, meaning those values are neither positive or negative, they're 0. Everywhere else between 1 and negative 2 should be either positive, right? It should be a quadratic that either is opening up or opening down. It actually figured out based on that fact. Right, we're going to walk you through it, but just to sort of understand the logistics of it, I know it's a parabola that's opening up, right, because of the positive square term. I know it hits a 0 at negative 2, and it hits a 0 at positive 1. Well, if it's opening up, it has to have this shape. Right, so based on that, once I get it all said and done, I know that it should be negative between the zeros and positive on the outside of the zeros shooting off to my infinities. And we'll see that that is the case. But always a good idea to sort of in the back of your mind understand the shape and what's going on with the problem. Alright, so between the zeros, we're going to break down what we're going to call into intervals. Alright, so our intervals are between the zeros. So the first interval is from negative, that would be this first piece. From negative infinity to negative 2 would be the first piece. And then the middle piece, between the zeros, that's my other interval, negative 2 to 1. And then the third piece. 1 to positive infinity. Those we're separating the zeros. We're separating the values between the zeros. All right, so I get 3 intervals. So I get between them, and then the outside edges going off to infinities. And we want to know between them when they're positive, when they're negative. And again, I already kind of know based on the picture of what it should be, but I'm going to test it and make sure it actually is that case. And so we set up a table. All right, so we create a table for those intervals to test x values and see if my function value comes out positive or negative. And so my 3 intervals we write here. So my intervals, my first interval goes from negative infinity to my first 0, negative 2. Between my zeros, negative 2 and 1. And then from my positive 0 to positive infinity, right? Those are the values. And then we just pick any test number. I picked negative 3. Right, but you could pick any value you want as long as you're picking something between, so negative 5, negative 10, negative 100 if you wanted. As long as it's a number between negative infinity and 2, then you're testing it. And you're plugging it in, so what we're doing is we're plugging it into the quadratic to see if it's positive or negative. And so when we take negative 3 and plug it in, we get out the function value, the y value, 4. Well, 4 is positive, so it's positive on that piece, which is what I guessed. All right, then we test between the zeros. 0 is always a good, right? 0 lands between negative 2 and 1. You pick any value between negative 2 and 1. Between a negative and positive, 0 always lands. So it's always an easy number to pick because I can solve that real quick. I plug 0 in, I get negative 2 out, and so that comes out negative. And then the last interval, 1 to infinity, I pick a number between 1 and infinity. Any number works. I pick 2. When I plug 2 into my quadratic, I get out a positive 4. And so that told me that it's positive on the tails, negative between them. And that is what I was guessed here, right? Positive on the tails, negative between the z-scores. And so the answer is, then reading it off the table, we're looking for the positive numbers, right? We were solving this. We wanted to know when it's positive or 0, so we want the positive and include the zeros, right? Greater than or equal to 0 is what we were solving for. And so the positive pieces were those intervals. So when x was between negative 2 to infinity, so as long as x was less than negative 2, it was positive, or bigger than positive 1, it was positive. We include those endpoints, we include the zeros. And so the solution set written in interval notation is this particular function, and it is what we guessed it was going to be. Right? If this was the shape of the graph, that was negative 2, that was positive 1. It's positive from negative 2 to negative infinity. It's also positive from 1 to positive infinity on those tails. It's negative between them. Alright, but this is usually the table. And like I said, this emulates something similar that you do with derivatives in calculus. Alright, so we're going to do another example, setting up a table. So we're going to do this one all set up. So first thing I have to do, again, I want to write the solution set in interval notation, solve it using the table. The first thing you have to do is set it to 0. So before I get started, I'm going to distribute my x. So I get x times x, which is x squared, minus x less than 6. Move the 6 over, and so the quadratic I'm going to solve is x squared minus x minus 6 less than 0. So I want the negative, right? This is asking me for the negative part. All right, not including 0. Alright, so 0 will be my boundary, but I will not include it, so it means I'll use parentheses, not brackets. Alright, so first thing we do is then we find those zeros, find those boundaries. So x squared minus x minus 6, which you can solve graphically, quadratic formula. Again, this one's pretty easy to solve by factoring. It's an easy case where x splits up into x squared splits up into x times x. Factors of negative 6 that add up to negative 1, well, negative 3 and positive 2, right? If I take negative 3 and multiply it by positive 2, I get negative 6. If I take 2 and add negative 3 to it, I get my negative 1, so it checks. So my zeros are at 3 and negative 2. All right, those are my zeros. Which means those are my boundaries. Between the 3 and the negative 2, it should be positive or negative. On the edges of 3 and 2, so going off from negative 2 to negative infinity, or positive 3 to positive infinity, those should be my positive and negative value. And actually, I know it opens up, so it means the negative is going to be between them. but we'll test it and verify that's the case. And so the intervals that we want to test are from negative infinity to negative 2, right? There's a 0 at 2. And then between the 2 and the 3, and then from 3 to infinity. Over those intervals, the function should be positive or negative, depending on the shape of the graph. And based on understanding the graph, I'm going to guess it's positive at the tails and negative in the middle. And I'm going to set up my table to solve that, test that. Alright, so my intervals first, so negative infinity to negative 2, negative 2 to 3, and 3 to infinity. Alright, test x value, the y value that went with my function, so x squared minus x minus 6, plugging it in there, and then whether it comes out positive or negative. Alright, so anything between negative 2 and negative infinity, so I would pick negative 4, so I'm going to plug negative 4 into my quadratic, and so you're going to get 16 minus a negative 420, and so 14 comes out positive, or the word positive. And then 0 is always a good number to pick, right? Between negative 2 and positive 3, the number 0 lands, so 0, plug it in, I get negative 6, so that's negative. And then I can actually stop there, but I'm going to finish it out and double check my answer. So 5 is a good number between 3 and infinity, so again, I'm plugging it in here. I'm going to get 25, 5, 6, and so it comes out positive 14 as well. And that's positive. Remember, I wanted to know where it's negative, right? I'm solving for the negative. And so the answer I want is this one, right? That's part of the table. And I do not include the 0, all right? So the solution is the set where x is less than 3, greater than negative 2, or using interval notation, the negative 2 to 3, where I use parentheses, right? Because I don't include the boundaries. I don't include the zeros. So I can plug anything I want from negative 2 to 3, not including negative 2 and 3, and I will get out a negative number from my original function, x squared minus x minus 6 less than 0. If I pick anything between negative 2 and 3, it'll come out negative. And that's it. If I only pick values there, if I pick values outside of that, it won't be negative anymore. It'll either be 0 or positive. Right? So those are the only numbers I want between 3 and negative 2. Right? And that's my solution. Alright, the last thing from these sections, we're going to solve a few simple applications of inequalities, and that will wrap up this part of the quadratics, solving inequalities.